Okay, so another topic that we're going to discuss is inelastic collisions. That happens when objects collide and they get stuck. For instance, here you have mass 1 and mass 2. They are coming at each other and then they collide, but after the collision they become one object. They get stuck together, so they have a combined mass, and they have a common velocity. And again, the conservation of momentum works. So we have that the initial momentum have to be equal to the final momentum. What is the initial momentum? The mass of particle 1, right? So mass of 1 times velocity of 1 x initial, right? Plus the mass of 2 times velocity of 2 in the x coordinate initial. That's equal to, now you have the two objects combined, right? So they have a common mass and they have a final velocity. So that's the way it's going to work, and we've seen problems like this already. So here's one, for instance. We have these two objects, 1 kilogram and 2 kilograms. They are coming at each other with these velocities, and after a while they collide and they get stuck. What is the final velocity? So let's just do our conservation of momentum. So we have initial equals final. So what is the initial? Well, it's the mass of 1, which is 1 kilogram, times the velocity of 1, which is 4 meters per second, right? And this K doesn't look like a K, so let's just make it a little more like a K. So plus the momentum of the second mass, which is 2 kilograms, times the velocity of the second mass, that's minus 2 meters per second, because it's going in the negative direction. That's equal to the final momentum. What is the final momentum? Well, it's the combined mass, which is 1 kilogram plus 2 kilograms, right? Plus a final velocity. And now we can solve here for the final velocity, right? So we can solve for the final velocity. We're going to get that the final velocity is equal to what? We're going to get 1 plus 2 kilograms at the bottom, right? This quantity. And on top, you're going to get 4 minus 4 kilograms meters per second. And so on those two, actually, they are going to stuck together and they are not going to move. So this guy is going to come here, and eventually you'll have this object that is going to just stay there. So let's look at another example. We have two trains and they are coming at each other. Train 1 has this much mass, train 2 has this much mass, and these are the initial velocities. 1.5 meters per second, and B2 has an initial velocity, and the final velocity is minus 0.25 meters per second, but the two trains, they get stuck, so now they are one. And we want to find the initial velocity of train 2. That's a question. So let's see how we do that. So we have initial and final, right? So initially, what do we have? We have the mass of 1 times velocity of 1 initially, plus the mass of 2 times velocity of 2. This is what we want. So fine, after the collision, we have the two masses combined times 1 velocity, right? So now we can do the algebra, right? So we can solve. So this is what we want. We solve the algebra for that. This is the equation after we do the algebra. And then we put in the numbers and we get that is minus 1.1 meters per second. So this guy is coming at a velocity of minus 1.1 meters per second. That's that number there. So that's all we have for this. This is a short video, and that covers all of chapter 9, the main points that we're going to touch in this class. So I'll see you in the video for energy.